Hi, my name is Nishchay Rathi and this is the lab report for my Physics 2 Lab 1. In this lab, we will rip a U-tape of a base tape, hence transferring electrons from the U-tape to the base tape. This would create an electron deficit on the U-tape and we can measure this charge by using free body diagrams and gravity. In this experiment, we take a tape on a table, stick another tape on it and quickly rip it off. We repeat the same with another tape. We would expect that if we brought these two U-tapes close to each other, they would repel. And when we do observe is that they do repel each other, which means that they have the same charge. And if we put the U-tape close to another neutral object, it gets attracted to the neutral object. If we take a plastic pen or a rod and rub it against our hair, we create negative charge. And if we bring the U-tape close to the object, we observe that it gets attracted. Hence, the U-tape must be positively charged. For the main experiment, we take a U-tape B and suspend it between the two raised platforms. We then bring another U-tape A and observe tape B defy gravity, or in other words, float. We then measure the distance between the tapes. Now, since tape B is no longer moving, its momentum is zero, and we can hence conclude that the net y component of the force on tape B must be zero. It's the earth which exerts a gravitational force downwards and the tape A which exerts an electric force upwards on tape B. Since the net y component of the force on tape B is zero, it must mean that the magnitude of the gravitational force is equal to the magnitude of the electric force from tape A on tape B. In the main experiment, the measured tape length was 20.1 centimeters or 0.201 meters. Since we know that the tape is 1 gram per meter, we can conclude that the mass of the tape is 0.000201 kilograms. We can use this information to calculate the forces on the tape. So the gravitational force is equal to mass times the acceleration due to gravity. And using this, we can say that the magnitude of the gravitational force on the floating piece of tape is 0.0019 newtons. The magnitude of the electric force must be equal to the magnitude of the gravitational force since the tape is no longer moving and hence must equal 0.0019 newtons. A note over here that the gravitational force points downwards whereas the electric force points upwards. The distance between the two tapes when one began to float above the other was 0.0248 meters or 2.48 centimeters. The magnitude of the charge was then calculated using this glow script code, and it was shown to be 3.67 times 10 to the minus 9 coulombs. We did make some assumptions and approximations as we went through these set of calculations, and it was that we ignored any air resistance on the moving object, but that's because the object was not really moving so fast that it would experience any significant air resistance. We also treated the long tape as though it were a point charge with all the charge concentrated at the center of the long tape. And then finally, we assume that each of the U-tape has about the same charge evenly distributed along the entire length of the tape. What fraction of atoms gave up their electrons? Going through these calculations, we found that 1 in every 8,275,862 atoms gave up their electrons. What if the electrons had a positive charge and protons had a negative charge? Would we observe any change in the observations we made with the tapes and other charged objects? Because we are dealing with only attractions and repulsions over here, and like charges will repel whereas unlike charges will attract, it would not matter if the electrons had positive charge or protons had negative charge. All our observations would stay the same. And then finally, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with our hands or other objects? Well, this is because if it does come in contact with a neutral object, it could discharge and we could hence not observe what we would want to observe. Conclusion: we can conclude that the net charge deficit on a tape creates an electric field similar to that created by a point charge, and this creates a force on similar tapes and they can repel each other if they are like charged. Thank you.